All right.
All right,
We want
onward.
to go back to the next section. Oh, this is my section. Cool. Service monitoring with Helix and Surveyor. So I think we had a question that popped up mainly around observability. Like, what does observability look like? And at the end of the day, like by default, Nats is observable, right? You can see what kind of messages like come in, and you can see those replies that come out. We call this like matrix mode or wiretap mode, where you're able to say, oh, I'm going to sub to like everything in this particular account, and you can see all of the messages that are coming through. Now, so that's observable by default, which is great. But what about like getting things like latency and RTT between requesters and repliers and everything like that? Well, one of the little known features inside of the NAT server is this idea of latency tracking. Where specifically with your services, when you work with imports and exports, you can get all this latency tracking information. It's a big JSON blob that I'll show you guys in just a minute, and it's really really neat. What you can do is you could also run a service that is open, or a service that is open source that we've created called Surveyor, NAT Surveyor, not only to monitor kind of your cluster metrics, but also monitor those service observations as well. Put them in stuff, put them in Prometheus, or have Prometheus scrape it and make charts and stuff around it. Now that's a lot of kit to set up. You got to set up Prometheus and Grafana. You got to set up Surveyor and make sure it's running properly, and then you got to make sure you set up all your imports and exports. And so we do walk people through like the process of doing this, but we've also been working on a commercial project to like help make a lot of that stuff easier. And so for years now, I know Derek's been a really big advocate of not doing open core and of kind of putting our best first in terms of the technology, because we really want to optimize for ubiquity here. Like, we believe NATS is a really superior solution for a lot of things, and we love to see it adopted more and more. But we're also wanting to make sure that we can help organizations kind of figure out like how do you not only how do you kind of deploy NATS, but how do you like manage NATS in production. And so that's where we want to come in and help. And so we've been working on this commercial product called Helix that I think you guys will be pretty excited about, especially if you've worked at all with like NSC tools, and you really like the idea of our decentralized auth, but know that, because it's decentralized, there's some like ergonomic issues that naturally come up with it. I think you guys will be excited to see what this is. So I'm going to quickly kind of give you guys a little tour of this product that we've been working on, Helix, and then we'll get into how do we set up latency tracking in Helix, and then break down, here's all the little like insides that go into it. So I'm going to go ahead and share my screen. And just keep in mind, this is software that is under development. I mean, we're working closely with some of our enterprise customers to make sure that we can, handle organizations' requirements here. But this is still very much in development. It's actually, you see, it's running on localhost right now because I have a branch here for this demo because I wanted to make sure things were all running properly. But we have a team behind this that's doing a lot of really good work, and we're excited, and we'd love to figure out if you guys are interested, or you have NATS in production and you want to either get feedback or get early access to this. Feel free to talk to us. Hit me up on Slack, or hit up sales at Synadia, and we can have a conversation about it. So the idea around Helix is it kind of manages multiple NAT systems. I just have one single, NAT server that I'm managing here, but this does super clusters and all of that. You can see I only have one cluster with one node in it. But you could also see I'm collecting metrics around this particular cluster, just overall high-level metrics. And again, this is all Prometheus based. So if you wanted to go nuts, you could still fire up a Grafana dashboard and point it to this Prometheus instance and have a good time, which is great. You can also see, again, your nodes. I only have one here for my server, but I can see a bunch of information about it. The more interesting bit is, like I said, if you've ever messed with NSC, or maybe you're managing accounts still in a configuration file and you think that's kind of painful, this allows you to manage your accounts and your users and everything about them, as well as your streams, all inside of this web UI, which is really, really neat. We also have an API for it, which is kind of cool. But I'm going to go ahead and just create a brand new account for this. I'm just going to call this, let's see, Rethink. And you can see I can configure default permissions for this Rethink account, or I can set limits for it. I'm not going to do any of that. I'm not even going to enable Jetstream because we're just going to be doing regular old services. So I'll hit save, and I'll go see where that account ended up, it's right here, rethink. And we don't have any data for this account yet, but you can kind of see we can inspect parts of the jot, and we explain various aspects of what these things mean. You can also kind of see if you do have limits on your account, like how close are you to those limits. We kind of marry this idea of limits and observability together so you can help make good decisions as a team. But let's actually see what jot this created. I'm going to go ahead and copy this jot. I'm going to say jwt.io just to inspect this jot. And this is all public information. Nothing's private about this. So you can see the name is Rethink. We don't have any limits on this particular account. We'll revisit this when we start adding our services to see kind of what it generated for us. Because again, all this stuff is possible inside of the NAT server. Just requires, kind of duct taping a couple pieces together to get it to work. All right. Let's create ourselves a user. Let's say I want to create a microservice and I need a user to, actually have that microservice be authenticated with this account. So I'm just going to call my user Jeremy, and I'm going to give him everything. Of course, I can lock down, say allow pub, allow sub. I can add all of these permissions for him. I can also, set particular limits like we were discussing. I could set them all here in this user account. I'm going to hit save. And now I have a user that is already created for me. And I could download the credentials file for this user. I'm going to save it as user in the right directory. And there we go. I've downloaded my credential file without having to touch any like a tool like NSC or anything like that. I've created a new account. I've created a new user. That account's already been pushed to the NAT server, which is pretty cool. And now I'm going to share my screen for my terminal to show you guys a little bit of how I'm going to set up this particular service. So let's go over here. All right, I'm in my terminal, and I'm just going to create a nice like echo service, right? So I'm going to say nats, and I'm going to use the nat CLI for this. Nats reply to the echo subject. And one nice little feature of the NATS CLI for replies is you can actually just tell it to echo back whatever you send it, which is nice. And then they also have this really cool sleep flag where I can say, I want it to sleep anywhere from 0 to 100 milliseconds and just randomize it. That way I can kind of like simulate, a service responding. Now, 100 milliseconds is a lot, but we'll reduce that in a sec, and we'll hopefully see our latency metrics go down. So let's test this out. I'm going to say nats request echo hello, and it just throws hello back to me, which is great. But if we wanted to simulate some real traffic, we probably just want to keep pounding this endpoint and send a bunch of traffic to it. So I'm going to send count to 0, which means it's just going to keep sending stuff over and over and over again, or at least 32,767 of them to be exact. And so now I'm generating more traffic inside of this account. And not only should we start seeing account metrics pile up for this, but what we're going to do is we're going to hop back over to Helix, and we're going to actually create a service out of this. So imagine right now that I have this echo service running in production, right? And now I want to actually have some monitoring capabilities around it. So let's hop back over to Helix. Apologies, I have to keep kind of sharing and unsharing my screen. Here we go. We're back in Helix, and I'm going to hop over to that Rethink account that I was back on right over here. And you can see inside of this account, we're already starting to collect some data. We scrape about every 10 seconds or so. And so we'll see this kind of flush out more, but you can kind of see we're sending about 4.9 messages a second. And the bytes that we're receiving, so nothing too bad. We're not sending a bunch, and that kind of makes sense given that we're 100 milliseconds ish of latency for this particular service. But if I go over here to this services tab, I can actually create a service and I can monitor it. I can also share it with other accounts. And so I'm going to go ahead and create my Echo service. I'm going to name this Echo, and I can give it a description. This service echoes what it's given. Okay. And then I can give it the subject. I can give this a wildcard if I wanted to, which is actually really cool. But I made the subject echo, so that's totally fine. And And then you can see right here, we have metrics where I can enable or disable metrics tracking. And I want to show you guys kind of what it looks like when I enable metrics. It's actually really, really neat. You can also set a sample rate. Maybe you have a particular service that's just getting hammered, like thousands, and it has a lot of horizontal scalability, and you don't want to generate a bunch of data for it. You can actually set a sample rate to lower, so you can kind of approximate metrics, but not necessarily like overload your time series database or your network traffic. Okay, so I'm gonna hit save, and I've created my service. Again, one more time, I'm gonna hop back over to my terminal. And inside here, you're going to see, oh, there's a lot of data actually flowing now. What is that data? What in the world is that? So that's actually some of our latency tracking that's getting produced by the NATS server. NATS server knows about all of this and can actually produce data for that service. And I'll show you guys what that actually means and how you do it inside of a JWT. But Helix set all this up for us very easily. So I'm going to say NATS sub this subject $Helix dot greater than. You can see I have some stuff flowing here. Let's look at what one of these look like. I'm just going to copy this and I'll echo it into JQ just so we can see it better. Cool. All right. So this is kind of an event that's being thrown out on a particular subject whenever we get a request and a reply from a service. And you could see that the type of service latency has its own ID and timestamp. It also gives you a status, and we actually record different statuses. So 200 means everything went well, but if you maybe you have somebody who's like sending publishes, which I'll do in a sec, sending publishes instead of requests, like there's no reply header existent, that's going to result in a 400. Maybe you're getting a lot of timeouts on that service, like the server knows about that and can report 408s in those instances. And so you can actually record errors automatically as well, which is really cool. Great. And so not only do we get error tracking, but we also get really detailed metrics around who the requester was, what kind of client they came from, what kind of version of the client they came from, what they've named themselves, as well as what account and what JWT they're coming from. So you can imagine as you're monitoring your service, you can get a better idea of exactly who's requesting this stuff and break those down into time series labels and things like that very, very easily. Not only that, but you get all the info about the responder as well. So you might even be able to get some more detailed information around, who's requesting this and where are they from, what particular server in the cluster or its supercluster are they connected to, why are they getting, what is their RTT? Is it due to their own network latency because they have to make a lot of hops, or is it due to the server, or is it due to the service? You get all of that stuff broken down into, what you would kind of look like, what it would kind of look like running like a time command in the terminal, where you get a service, system, and total, which is really, really neat. So that's kind of the breakdown of these events. Let's actually hop back over we're going to hop back over to Helix, and I'll show you kind of what this looks like in terms of charts. So I'm going to share my Helix. All right. We're back over to Helix. I'm going to click on Echo, and you can see that we're already tracking metrics, which is really cool. And so I've been, firing this stuff in the background, but you can kind of see where the service latency is kind of hovering around, total latency, system latency, throughput. We don't have any errors right now, which is great. And you can see this is our P50. We have a distribution set on this in the background. It's a histogram inside of Prometheus. But you can also see, hey, what's my P99 here, which is really, really helpful, right? You can break all of these things down very easily, set different times for it. And so this is just really nice high level overview, and it's stuff that we want to continue to invest more in. And again, if you want to go deeper, you can throw a Grafana dashboard on top of this, and it's all very accessible. But this is a nice kind of at a glance, hey, how is my service doing? Are there any things that kind of stand out? I'm not going to show you my terminal, but for a second, I'm also going to just start generating some errors. So I'm going to say nats hub echo, and I'll just throw a bunch in here. And hopefully in about 10 seconds or so, we should be able to see a lot of errors generated. In the meantime, I kind of want to show you, like, how does this all work? How does a server know that this thing's a service, and how does it know how to track the latency and at what sample rate? And to do that, we're going to go over to our account. All right, this is our account overview for Rethink. You can kind of see we're also tracking account level metrics, like I said, and those are going up as we've been sending messages. I'm going to copy this JWT. Actually, I'm going to make sure I refresh the page because I think I haven't yet. That might be a little bug. All right, let's go back to our lovely jwt.io. Let's see how this breaks down. And so you can see now that this JWT is bigger, right? It has some exports and some imports. First of all, it now knows that it's exporting this echo service. And we're saying we want to track service latency on this service for a sample rate of 100, and we want to send it to this subject. So every time, because it's sample rate 100, that this service responds or receives or responds to a request, the server is going to emit that event, JSON that I just showed you to this subject. And that's when Surveyor comes in and collects information on that subject and puts it into a time series database. The fun part here is I've been interacting on my account the whole time. And so another little trick that we can do, and this is available in recent versions of the NAT server, is I can import my own export. And so I could say, hey, I want to import my echo service into myself so I can also get latency tracking for things that are happening inside my account. And so this all kind of comes together into a nice little set of tracking. Look at, we're already getting some data points for, whoops. We should be getting some data points at this point for errors. Yes, we are. Let's go to the last 5 minutes. And so you can see our error rate went up to 557 per second because we were sending a bunch of publishes with no replies, and those were coming back as 408s. As 400s. But you can kind of see, yeah, we can measure all of this stuff. Also, when we were making a bunch of publishes, it looks like our latency went down a ton because, you know, those things never got responded to. They just got received and then eventually errored. So again, this is all in development software, but I wanted to show you guys just kind of how cool it is. And when you string a bunch of things together into the NATS ecosystem, you can come up with something really, really neat. And in a lot of ways, this kind of gives you information that you can't even get very easily with HTTP itself or with a load balancer or anything like that, because you can imagine you're getting request RTT from the client to the server, to the NAT server, from the NAT server to the responder, and all the way back again. And that's just really, really neat information, getting all that metadata about where that client is, where it's located, what kind of server it's connected to. You can imagine this humble little set of charts right here can actually expand into something so much more intelligent. So we have big plans for something like Helix. If anybody's really interested in trying this out or seeing how you may adopt it, let us know. We'd love to, engage in conversation with you guys. But that's so far what we have in terms of latency tracking and how it looks like for your services. So I'm going to bring Byron back, and we'll move on to the next section. Or we can use any Q&A if there's anything that kind of popped up in the meantime. Close this out. Okay. Somebody asked, how can I get access to Helix? Yeah, just talk to us. Again, it's still in development. It's something we're probably wanting to continue to roll out. We'll roll out early to customers, like, towards the end of this year, and continue rolling it out into next year. Figure out, what the right sizing is and everything. We're still figuring out, what it looks like from a packaging perspective. But we really want to work with organizations who are, using NATS at scale or using it in, multiple teams and things like that, and who could benefit from it. So. Great. So Andrew says, I've been working on accounts and users for our NATS clusters for a few weeks now. This looks much nicer than dealing with NSC. Yeah, and NSC is kind of meant to just be a utility tool for, something that's by design decentralized. So there's going to be some finicky parts of it from the fact that, we're saying that by default doesn't have any opinions on where this is stored. But when you start bringing in an opinion, like saying, hey, we'll have a web app that kind of manages all of this for us, and we're okay with that, then yeah, you can start making the UX a lot better. And that's really where we want to try to play, where our open source technology is as generalized as possible and can fit as many use cases as possible. And then hopefully some more of our commercial technology can better fit, very specific instances of how people use the system. Great. Andrew says, love to try this out. We shop monkey are still really early in our development and usage of NATs, but this would be useful. Great. Yeah, really love the feedback. Love to engage and kind of hear your use case, learn more about your organization. Every organization is very different, so we want to make sure that we try to cover, the gamut here. Great. Exciting stuff, guys. Well, Byron, do we want to move on to the next section?
Yeah. Yep.
All right. Very cool.
That was a great demo, Jeremy.